All right, well, welcome. Thank you very much for joining us today. Today we're hosting GoodWe and a new string inverter company that we picked up late last year. So anyways, I'm Kyle Smith. I'm the president of Supplied Energy, and I would like to welcome Jock and Brulio of GoodWe, and they will be presenting today. And sorry, I've got a phone ringing in the background. I don't know if you guys could hear that, but I apologize if you heard it. Harrison will be joining us as well from an MC perspective on the Supplied Energy side. And he's having a little technical difficulties coming in today. But a little bit on us. We're Supplied Energy. We're located in Austin, Texas, Catoosa, Oklahoma, which is Tulsa Metro, Greenville, Illinois, which is the east side of St. Louis, and Noonan, Georgia, which is just southwest of Atlanta. And then the services that we provide, if you ask us in one word, what are we? We are a distributor. We're a wholesaler. And we sell heating, cooling, solar, storage products to contractors who then resell to their customers. So we offer services that of being a distributor, a development energy provider, a partner, where we work with developments to help scale out their electrical infrastructure for renewable energy. We do a retail sales function where we help installers sell their projects. Design services where we design in the products that we sell and offer a full bill of materials and performance package for our customers. Training, on the roof training, that's where we excel. Renewable energy planning for those developments and companies and individuals who want to have a journey or a roadmap on their path. We do piping fabrication, that's easy for me to say, in our Catoosa, Oklahoma location. And then we also do feasibility studies for solar and geothermal products. And we sell to installers, developers, loopers, home and building owners, electric utilities, builders, architects, engineers, and we may or may not sell directly to them, but we're at least working with them as evangelists of ours. So we offer heat pumps, what we call power products, meaning that could be generators, storage, solar, energy monitoring and load management is a huge part of our future, we feel, water heating products, and piping and fabrication. So what makes our path, what makes us special? Well, we feel a lot of things, but whenever you look at a specific building or a home, we believe in a 4-step process. And no matter what, insulation never fails, insulation never breaks down. So we believe in making a space as tight as it possibly can be and controlling your environment of the home. And it doesn't require service. It doesn't require wear and tear to be fixed. So that brings you to step number 2, which is the all-electric heating and cooling system, as well as water heating. So if you look at the average home, 75% of the users of a home of the energy in a home is the cooling, heating, and water heating. If you can take care of those big loads, the remaining 30 to 25% really don't matter. They're just small things that need to be replaced. So that means that we can have a higher percentage of load coverage with our solar array and be able to have a better approach to the load of the home for our solar, and number 4, our battery backup potential. So anyways, GoodWe products, we really feel fit right into that, really the heart of the home. And so here's a little bit of a image of a home where just some information about whether it be tightening the envelope, the solar being generated, the geothermal or air source heating cooling products that go into a home. And it's more than just one system. It's a whole bunch of products combined to meet the needs of the home's net zero future, I'll say. And that's another thing is we sell net zero. And we also sell what's best for the consumer and what's best for the home. a little bit on GoodWe. We picked up GoodWe, I would say, I think it was late last year. We finally, we've been talking for quite a few months, and we finally got some things moving. I had personally heard about GoodWe for a number of years in Europe and Asia, and had been following them for quite a while. And I saw that they were in North America now. And Michael and I from GoodWe's talked, and Travis, we talked summer and fall last year. And I think late last year or January, we got our first product in. But we've been watching the GoodWe product. We've been learning more and more, and we feel like this is we're really glad we made this move. We moved away from one of their competitive products, and for the string inverter solution, we feel like this is a great move that we made, and we're very happy that we did so. So with that being said, I'm going to stop sharing here and go over to Jacques and let you present. I will be answering any questions as they come up as well. Any questions, like I was saying, or comments, I'll try to jump in. I'll wait till the end possibly, or if it's good timing, just go ahead and dump those in as well. So I'll hand it over to you guys.
Thanks, Brawley. Unless you have any introductory words, I'll just get started. Let me just pop in.
No, you take it away, Jock. Just thank you, Kyle, for the introduction, and we're very excited to work with you. I don't want to steal Jock's thunder in terms of talking about GoodWe, but we're definitely excited into tapping into the market that Supplied Energy is covering, and we're just very excited to be a partner of yours. So hopefully today, you'll find value into the presentation that we put together. There's a lot of knowledge and wisdom that Jock is going to provide today. So take us away, Jock.
So just checking, because I got a Zoom message for a second. You see everything fine?
I do not.
Yep. Oh.
Yeah. Okay. Thank you.
Just your face.
Oh, just my face. So I'll reshare. Thanks, Kyle. Now you should see it. Okay, great. So Jock Patterson, my name is on the screen here. I've been with GoodWe for a little over a year and a half. I've been in the industry for 15 years, and I'm presenting on our products in our current generation and what's coming future with a focus on PV inverters. We also do energy storage, and we will touch on that, but we'll focus on PV inverters. The best place always to start is, who the heck is GoodWe? So GoodWe started in 2010. They are based in China, and that's where they manufacture, but they are located around the world in terms of sales. We have 10 subsidiaries, but we sell in 30 plus countries. The focus has been on PV and storage inverters, but the fact is we manufacture batteries now and all the accessories and the software. And that's because we have the ability to design our stuff. We're not just like a contract manufacturer. We design our own devices and software, and that's why we have a big R&D team. And this work has been recognized in the total number of shipments we have of our equipment, our inverters, and the quality. So some of these accolades aren't going to be recognized. People go, I don't know what that is. IHS mark. Well, sure, because this is an international company. So let's talk more at home in the US. We're new here in 2021. We're providing to North America. So that's not just the US, Canada, and supporting Mexico and the Caribbean. And we've been talking about our number of shipments and saying that indeed we are a quality inverter going around the world with low failure rates. And that all sounds great, but who in the US has actually vetted this company? Who can we rely on it as a company we know saying these guys are good quality? Well, GE chose us out of 31 other companies that were competing for GE's desire to get back in the residential inverter space. And they chose us because of our manufacturing, our management, our quality. And so you see in the bottom center and right, two inverters that look virtually identical. Well, that's because they are virtually identical. The one on the right is the GE version. So GE is using us to make their residential inverters. What do we have for you in the marketplace? Well, and we look on the two inverters at the left side and we see a chassis on the far left that's designed for single phase. And that's for a PV only inverter, that's 240 or 208. For an energy storage inverter, whether it's a hybrid or just plain battery inverter, it's 240. I'll talk more about that inverter in a second. The next one over is let me get my little laser pointer out here. The second one here is our first CNI inverter. It's a 480 volt designed for Delta or Y configurations and is a 50 or 60 kilowatt inverter. We're not going to have a focus on this, but know that it's there. And if someone has questions about this, we can get into it, but I'm not just presenting it because we're focusing on the single phase for this presentation. We'll be moving over to a new chassis for both PV and energy storage. I should actually say we're separating out instead of being in the same chassis. We're designing one that's ideal for a PV environment, and the other one that for energy storage. So that's what's happening later this season and into the summer. But what's out there in the marketplace right now? This chassis with 3 different series. So we've got our PV only, our battery only, and then you take those 2 features and in the same chassis, you have a hybrid. All 3 of those are similar in their power classes from 5 to 9.6. That's 6 power classes, but the key ones are 5, 7.6, and 9.6. Again, they share the same chassis. Inside the wiring compartment where you do your work, you'll notice there's an embedded smart meter. And inside the packaging, not just the inverter, there's other things in that packaging you want to make sure you don't throw away. There is a set of CTs that connect. Now, for PV installations, you don't need to do this. You don't have to install the CTs. The CTs for the PV system were really designed in case you need to do zero export. If your utility says we don't want you pushing any extra energy out onto the grid, there's a way to limit that without having to get third-party equipment. We can handle that. But if you're just trying to monitor how much your inverter is producing, you don't need to install the CTs on the PV only. Inside the box is also what we call our Wi-Fi dongle. It's a communication device plugged in after you've done everything else, all the conduit and wiring. You plug this in, and this is the device that's going to communicate to the homeowner's router to send data out to our free monitoring site called SEMS. So you'll commission the inverter by connecting to this device, set up the inverter to be the right grid setting, and then you'll also tell the inverter how to talk to the homeowner's router so it can call home and you can go use the SEMS platform. We'll talk more about that platform. There's a standard 10-year warranty, expandable to 15 or 20 years. When we look at just a PV inverter setup, the power flows in the orangish color are pretty understandable. So I'm going to focus on the red and blue dotted lines. In the upper left, we are circling around the rapid shutdown device to remind you that we realize that rapid shutdown is required often, and therefore, rather than getting a separate device embedded inside, along with the smart meter, is a rapid shutdown transmitter. And you have 2 choices, a TIGO or an AP smart transmitter. So when you're ordering the product, don't just say, yes, I'd like that AMS 7600. Make sure you indicate whether you want the TIGO or the AP smart transmitter. The other red dotted lines is self-explanatory. We're just feeding loads. So I'll go right up to the blue lines, which are communication lines here, saying that the inverter can be commissioned with our app, and that app we'll talk about and viewed on the monitoring site via web browser or app. And I'll talk about that app too. So we have two apps that you can use to both commission and monitor the system. So why a GoodWe PV inverter? I would say the number one reason is, well, there's two very important reasons. One is reliability. There's just very low failure rate for the inverters. But number two is the design flexibility. You are able to have each string optimized. So for a house like the one pictured on the right, where you can put up a string in this location and then a string in the center roof, and then maybe a small string of 3 or 4 modules down here, each roof face, because there's a different orientation and maybe a different amount of soiling or a different amount of shade, will have its own optimization going on, because each string goes into its own MPPT, its own maximum power point tracking connection. So each terminal on the PV inputs is its own MPPT. That is, it's an optimizer at the string level. So when you're viewing the performance of the system, not only getting optimization, you can look at the string level, what's happening. So you're effectively saying I can look at each roof face separately in the monitoring portal. Oversizing, I would say fairly standard, 150%. You need to be able to oversize, especially if you're doing east-west arrays. If you have roof faces like the one on the right, where there are a lot of different sizes, sometimes you get some small ones and you can only fit 3 or 4 modules. Indeed, you can do that because we have a low starting voltage requirement. You wouldn't want to design all your strings to be 3 modules. It would work, but it would be inefficient. So you would just do that for 1 or 2 strings. With today's high power modules, you want to make sure that your inverter can handle the current they put out. For example, there's a popular inverter out there. It's been popular for years. 3-letter acronym. Won't go any further, but it can only handle 10 amps. Right, that's the amount of amperage. So if you have a module that's putting out 12 amps, it's going to have to cut off that module at 10 amps, and you're going to have some power loss due to that. Well, we can handle 12.5 amps. Now we're getting that point where 12.5 is now starting to cut us off at some of these higher power modules we're seeing. Luckily, we're bringing in a new inverter, so I'm going to talk about that. But this is still pretty high for our current generation, what we see out there at 12.5 amps. Remember that you choose between a Tigo rapid shutdown transmitter or an AP Smart 1. I'm going to be mentioning these terms, AC and DC coupling, so I'll briefly describe what they are. I'm not going to go into a lot of depth, but people throw this term out regularly. I'm just going to tell you that it honestly just talks about the type of current between the PV array and the battery. The PV is sending out DC current, and it reaches the battery without ever being inverted. That's a DC coupling. But we know in a real world, we don't always see that. What we see is a PV array going to a PV inverter, has its AC and DC components, and then we might have a PV array going to a hybrid inverter. Now, this hybrid inverter is an inverter that can take also a battery input. And the point here is that this hybrid inverter set up on the right side is future looking. It's saying, yeah, I think I'm going to get a battery someday. If I want to get a battery for the left side, I have to add a battery inverter. So that's a second inverter. And we see that the PV array actually goes through, its power goes through inversion to AC and then rectified back to DC. So we have AC coupling on the left. And on the right, we have DC coupling because we never take the PV array's power when we want to feed the battery and go to AC. We're staying along a DC bus inside the hybrid inverter. And so that's a very efficient movement of energy. So the way we look at this on the right is this is a new install when you want to have a battery, an energy storage system. On the left is having an existing PV inverter and adding battery to it. So that's the AC and DC coupling terminology. Battery systems, I'm going to go through this briefly because we're not focused on this. Just know we have this for AC and DC coupling. As I explained, we use high voltage batteries. It's more efficient connecting and greater flexibility. If you can't put your battery and your inverter in the same spot, and this is not uncommon, just looked at a site in Colorado where the inverter is outside because our inverters are NEMA 4X rated, so they could be in that environment. But the battery, doesn't, lithium ion chemistry, it doesn't discharge when it gets really cold out. So they put that in the basement. Now you have a 60-foot run of wiring from the inverter to the basement. How are you going to do that with 3/0, 4/0 cable? It's much easier with number 6 and number 8 building wire. And that's what you can do when you have high voltage. You can just use the thinner wire. There's a great DC bus here, 50 amps. What does that actually mean? It means the bottom line, you don't have, and you can't think in terms of 48-volt systems. This is high volt systems. So we're high voltage times that 50 amps. We get that. We're talking about a lot of power capability to move along here. We have operating mode, so you can set it up so the system discharges and charges, discharges and charges. For self-consumption, a great example of that always is time of use. If you have customers on time of use rate schedules, you can set up the actual charge and discharge to match the time of use rate schedule. Or if they just want backup, that's what they really are getting the system for. Then you can put it in backup mode and it always trickle charges the battery. So it's at 100% ready for when you do have a backup need. There are batteries we work with. I'll sort of skip through this now, LG and BYD, because again, I don't want to focus too much on energy storage here. I just want you to know these things are available. And then if there's a question about that, we can go there. This generation allows you to do partial home backup. That's how it comes out of the box, so to speak. But you can do a whole home with our own auto transfer switch, which we call the ATD. But let's get on installation of a PV inverter. When you work on these inverters, you're only ever working in the wiring compartment here. The upper electronics box is just that. It's electronics. It comes from the factory for factory setting only. You're not going to work in that. If there's any problem in the upper wiring box, we RMA the unit, right? Your job is to do the wiring in the lower box. When you're placing the inverter, it's fairly standard. We obviously have to pay attention to the environment. So while you don't have to have it away from the sun, you want to keep it away from the sun, right? It's just an electronics good thing to do. You don't have to keep it out of the rain, but you want to, right? So especially if it's going to be in the rain, while it's NEMA 4X, it isn't. Once you take out the gaskets, or the rubber enclosures around the pre-drilled knockouts. Once you take those out, you now have to put in appropriate and well done rain tight fittings to return it to a NEMA 4X type inverter. It's meant to mount on a wall, right? It's not meant to be laid down, this inverter. It can be tilted back up to 15 degrees, but it's pretty much a vertical inverter. When you open up the box, there's going to be the first thing you pull out, unless you're opening it upside down, the first thing you pull out is this template. And the template's got the holes for you to mark and drill for mounting. Make it a lot easier on yourself. Use this template. It's a cardboard template, so it's not like you have to tape up a piece of paper. You can actually hold it with one hand and mark the holes. And then you hang the inverter after you mount the brackets. This is a peek inside the inverter, the wiring compartment. It's got some of the wires, and none of the wires that were normally here that move up from the circuit board into the main electronics above are shown just for clarity. But the top device here in the center on a DIN rail is the smart meter, GoodWe's smart meter, and then the rapid shutdown device. Or transmitter. If it's green, it's a Tigo. If it's gray, it's an AP Smart. And then we've got the black area here is just all the instructions for the terminals, just labeling what they are. On the left side is PV inputs. We can have up to 4 pairs coming in here. It's only 2 pairs we use for a 5 and 6 kilowatt, but all the larger 7 kilowatt and up, 4 MPPTs. So 4 terminal sets. If we're not doing battery, you ignore this part, right? These may exist in here, but they don't do anything. Just part of sharing the same chassis with the battery design. You wouldn't be using those. Same on the right side. You wouldn't do the AC backup circuit connections. We're only concerned with the AC grid connection on the right. So your L1, L2 neutral. And then for each side, we have grounding equipment grounds. So there's a bus bar here and a bus bar here with set screws. And those are the only times you're using set screws that you have to think about torque. The rest of it is just spring-loaded input terminals. No worry about torque values. After you've done your PV and AC connection, then you can consider doing some communication device. But remember, the default communication is this Wi-Fi module. So you don't have to send anything up if all you want to do is use Wi-Fi. In other words, if you're not connecting to a battery and you're not trying to do a Modbus connection, then you're all good to go. PV, AC, Wi-Fi, you're done. What's recommended is you can get this crimping tool. There's a ton of them on the web that create this square crimp. We provide these what are called wire ferrules in the box. You don't have to use them, but we recommend you use them because if you ever look inside at the jaws of these terminals, they're square shaped. They're not round. Yeah, they're round going in at the insulation here, the dielectric. But when you want to insert the wire and you want to control those strands from splaying out, it's great to use this crimper. It's inexpensive, 25 bucks. We provide all the actual wire ferrules. You crimp them and they push in nice and easily, create good connection, reduce the chance of any connection resistance over time. So we highly recommend you use those, but you don't have to. The example here is showing all of the, in this case, 4 pairs of PV input circuits, all having the wire ferrules on them, all plugged in, and with illustration of the ground bar again. We're sort of showing the same stuff here, just in a graphic form. There is a DC, so a PV disconnect switch that's lockable. And that's it on the PV side. The AC side, you'll consider using, you can't use 8 or 10 gauge aluminum or copper preferred, and then here are your breaker ratings for those different inverters. So now you've physically installed the unit. Now you're going to commission it, and you're going to use your smart device, your phone. So we have a SolarGo app that's available on iOS or Android, and you will launch this and set up. For the PV, it's pretty easy. You're just going to set the right grid type, 240 volt. There are a couple choices because, for example, California has some grids that some utilities have specific settings, so you can choose those specific. Most people will choose the IEEE 1547 240. And once you've done that, you're generally done with the PV in terms of getting the inverter commissioned so it can operate. Right, we're getting it so it can operate. The next thing is going to be using the SEMS portal app to make sure it can communicate to the SEMS portal. So, and that way you can see it and your homeowner can see it on the SEMS portal. That's a free monitoring site. When you enter the app, you can I don't know if you guys still hear me all right.
Yeah,
We lost your screen though.
Oh, it's a screen. Okay, reshare. Yeah, I get the Zoom telling me. I might turn off my video just to reduce that. And let me try again here. it's a nice feature of Zoom to let you know that you've lost it. So if we're good, I'm showing this blue screen from the commissioning app, let you know where the power flows in the system and what the basic settings are. And then you're going to go into the more section down the bottom here, and you're going to get a selection of other menus to go into to change things. And 99% of the time, you're just going to be in basic setting. You're going to go in there and just set 240 and you're done. It may be necessary for some grids to change the advanced setting about voltage ride through or something. So you could do that. If you are getting messages, you can diagnose the problem, see the message. And if you need to turn on smart scan, you've got shade developing, or you got shade in the middle of the day. Don't worry about it in the morning or late afternoon, but if you got some shade in the middle of the day on part of the array, you might want to turn on our smart scan to deal with shade mitigation. So that's the basic outline of commissioning. Before you go do your first installation, you can set up a one-on-one call, and it may be with me, it may be with someone else, but we're going to go over your particulars of your first install. We want your first install to go really smoothly. So I'm going to talk about your first install, and we're going to go into these screens in more in depth. And that way you'll be right before your install, have this fresh in your memory. Just know you can do that, and we'll provide you a link for that. Pictured on the right is, now these are storage inverters, each one with their own auto transformer, which derives a neutral when you lose a grid. I didn't get into that detail because I'm avoiding talking about the energy storage because I want to focus on the PV inverter. But you certainly could have two PV inverters that look just like this side by side or more, right? You can have multiple PV inverters feeding into the same panel as long as you have the amperage overhead in that panel. These indicators, you see they're different colors, and you might go, "Oh, how am I supposed to memorize it?" It was well put by Kyle that the nice thing on the side, on the left side of the inverter, is a legend that translates all those colors and blinking rates to information of what does it mean? What is it telling you? Okay, so that was the first generation, focusing mostly on PV. Here's our next generation. So to illustrate what has really changed, I put in green font what's new. So this MSUS, the slicker looking inverter, has a higher power class, 11.4. It can do a little bit more DC AC oversizing. While we drop the number of MPPTs from 4 to 3 as a maximum, this makes sense given that, and let me use a pen here, given that the number of amps coming in now is going up, the modules are getting more powerful. You don't need as many modules on a site to provide as big a PV, to the same size PV system. So you don't need as many strings generally. So that's the reason in the change here. So we can, we're future-proof in terms of modules. 16 amps for a residential module is quite high these days. We see it moving that way. So you're covered for, unless you're going to find some 700-watt modules out there or 650-watt modules that are huge, not easy for one person to carry, and not really designed for residential. Unless you're doing those, you shouldn't have a problem with amperage. Here's an image of this new inverter. Its wiring compartment is smaller because we don't include, remember now in this new series of the PV inverter, we don't share the same chassis as we did with the previous generation that had the ability to share with the energy storage connections. We're not doing that here. It's just about PV and AC. And so the wiring compartment is more bare. On the far right side is in this case, an AP Smart rapid shutdown transmitter. And the number of lights is less, but there's still a legend on the side that explains, you can't see it here, but off to the side, And that's what one of these looks like installed. This newer series of storage inverters is a slightly different look. It has a bigger display. And I won't get too in depth with these, except that they're really designed for a whole home backup. So you have to get this backup device together with it in order to have a complete system. If you want to put multiple of these inverters at a site, you will need something to manage the fact that they're all competing to form the AC waveform when the grid goes out. You need a master or multiple parallel device. And that's what this is if you want to do more than one inverter at a site connecting to the same load panel. A nice thing about this new inverter is that the storage is that it offers an EV charging option. So you would have to order the version of that includes this EV charging board. But the point is that even if your customer only gets a 5 kilowatt inverter, it will still be able to output 9.6 kilowatts to charge a vehicle. So this means that we have a board inside here, and we provide a cable and a common coupler to connect to the car. So you want to think about where you're installing the inverter so we can reach the car. That is a special option, so you'd have to ask for that in particular. But it bypasses, the reason you do 9.6 is it bypasses the normal circuitry inside the inverter. So it can do 9.6 of charging power out of a 5 kilowatt inverter. Just remember when you're doing your breaker sizing and you have this option, that you think about the fact that you're doing 9.6 of AC pull and not just something less. You're not just pushing 5, but you're pulling 9.6. We'll have our own battery. We have our own battery from 9.6 to 19.2 kilowatt hours in a stack. You determine the stack height, right? You got to have at least 3 of these, but you can have all 6 to get 19.2. And so that's it on the presentation. I will again remark that you can, and we suggest you do, take this one-on-one class. That means there's no one else, not another company, just you and us talking about your first install. And we'll not just talk about the physical installation, but we'll go over again the commissioning details and any particular needs you have, like you're going to need 4G on a site instead of just Wi-Fi, for example. So that should be in a follow-up email. By the thing besides installation is the monitoring. So I'm going to try to stop the share here and then share a different screen. Let's see if that works all right. So hang in there for 1 second with me, and I'm going to share a browser screen so you have an idea when you go to log in and see these systems and you describe it to your homeowner what you're going to do. We're going to set up an account for you. So what you should be seeing right now is a login screen to SEMS, and we're going to set up an account for you. So when you log in, you're going to see all your systems. So I'm logging in here, and I see all my systems that I can see. And so it's like fleet management. If I want to see all the systems that are working, I can click on that filter and see all the systems that are working. And then I can drill down to any one system and see what it's doing. So again, this is going out to the SEMS portal, grabbing data and showing it on the browser here. And I can see that this system is indeed not producing, and it depends where this is located. It should be producing. We're in California. So that's a question for this installer to say, why isn't the PV system producing? So they should have a message. It's a working system still. It's able to charge the battery. It just isn't producing PV, and maybe the orientation of the array is such that that's why that happens. I don't know this system in particular. But you can see the power flows. And for a regular PV only inverter, you wouldn't be seeing the battery image here. You would just see PV coming in. And just so we know that this really exists. I'll choose another one in California here that is producing power. Oh, well, I just chose one that's battery only. Interesting. So that may have been the case with the other one. I chose a battery only system, right? It's for some reason it's I'm just looking out on, let me see if I can choose one that's just PV. That one's 0. Probably shouldn't choose that. Anyway, you get the idea. You can choose your systems. I didn't plan ahead on which ones to show. Oh, and you can see, by the way, these yourself before you even get an account. There's a demo button. So if you don't have a login yet, you can demo and see how the monitoring platform works. So
how about inverter? Is there any inverter diagnosis information from the installer side through here?
In here, you can see, so instead of having to come in to see if there's a problem, you will have reports where you can be sent a text or an email if there is a problem, right? So that's how the system alerts you. And then you come in and look at the problem, and it will also show you solutions. I'm not well versed in that part. I'll take a quick look here,
Understood.
but so here are a bunch of problems. I don't know which a good one is to look at, but it shows you the failure, possible causes, and what troubleshooting steps you should take. Right.
Oh, that's an improvement from our past. We have, let's generically say that we have some areas where we have some dirty power, where the voltage, or really just the voltage rise runs away, up north of 270 to 300.
Wow.
And yes, and so we don't really have a good understanding of why or how this happens, except that a competitor of yours, no names, has everybody pretty salty about their failure rates, and just being able to look at the better option of being able to diagnose and take a look at the projects to make sure everything's still operational and not have callbacks.
Yeah, so you should be able to look at the history. So we looked at what is the inverter doing now, but we can look at any time. So if I, again, choose the system, I'll wait for it to come up. Notice the date is up here. I can go back to a previous day, and I can see down here on that day, a certain time. I can zoom into the time. I can see what actually this is current stuff. So this is, if I want to see currently what is the DC voltage on MPPT1, I can see that. So that's the detail. But if I wanted to see what's happening at a particular time, I can set a date here, and then there's a way to, and I'm not well versed in this, so taking a chance here if I can remember how to, oh, there. So I can zoom in and choose a spot and see some information. Now, if I want to work with this in a table format, I literally can export it here to an Excel file, and it'll give me all the data in this range. So I can do some examination. And obviously being on this platform isn't just for your own benefit, but when you call for support, they will look at this and see your system. So it's great to have your system online so they can diagnose it. As far as the voltage in general, to me, we should be recording all those high voltages, and the inverter at times should go into momentary cessation or something because you've hit an area on the grid settings where you've exceeded for too long a time, and it either goes into cessation or it goes into full trip, depending on it, to protect itself, as it's supposed to do. So I don't know if that answers your question, but at least we're capturing the data. Okay, so that's the site. Now, everybody's that wants to do fleet management is going to set up an account, and we'll do that through the QuickStart class that you'll sign up for before you do your first install. But before you go out and buy this, right, you're going to have some more questions, and that's what I'm here for, and Supplied Energy is here for, is to make sure that you're comfortable with the equipment. So Supplied Energy knows they can share my contact information if you need help string sizing, or they're going to do it. I'm just here to, however I can help, to make sure you're comfortable with selection, and then we'll get you settled into buying something, and then going through the QuickStart class to make sure you're going to have good first time experience, and you don't have to do a second truck roll for your first install. So that's it for me. I will stop sharing and then see if there are questions. Bring my video back online. Hopefully I'm still here. People are here.
Yeah. No, you're
Yeah,
good. Sorry about that.
Yeah.
So we did have one question on, and I think it's a good question on rapid shutdown devices that are AP Smart or Tigo. I'll simply say, what's the why behind that?
So why those two companies? I mean, they're the two most popular selling brands from our experience for rapid shutdown. We can't do every option out there, but it doesn't limit you from doing other options. So if you didn't want to do AP Smart or Tigo, for example, if you didn't do rapid shutdown at all, you just didn't need it, you have a ground mount, you can ignore which flavor of the inverter you have, whether as a Tiger or AP Smart, doesn't matter. It's not going to affect you. You just ignore it. If you want to do, say, Fire Raptor, that's a third-party device. Again, you can ignore what's already in there. It's not going to affect it. But if you want to do a different type of sun spec transmitter, then you need to disengage. And that's exactly what we would talk about at a QuickStart class. We would say, all right, for your first project, you're going to use an NEP solution. I'm making these things up, right? To do rapid shutdown. Great. We want to turn off our signal. This is how you do it. So that's the reason we chose what we did, but it doesn't prevent you from doing other rapid shutdown, including no rapid shutdown because you don't require it, or you're doing a flat roof. It's a small flat roof. You're doing single phase, and you are using racking from a company that is UL 3741 compatible with us, right? So we're starting to earn these certifications where we're compatible, so you don't need any rapid shutdown. It's particularly designed for our three-phase inverter, but we're looking at trying to do it with our single phase too, because we know there's some single phase flat roofs out there.
Sure. Well, I think it just breaks down to even like what Supplied Energy carrying. In this particular case, we carry both. Really don't want to carry both, but at the moment we do have AP Smart and Tigo available on hand for rapid shutdown roof projects.
Good
and then
question.
it'll just depend on what the actually from a GoodWe perspective, just so we're clear, GoodWe sells say a 7.6 inverter in two different SKUs. And so, one would be an AP Smart SKU and one would be a Tigo SKU. So it's just one thing we got to make sure that we're consistent, when we do have a roof mount. But like Josh said, that if it is a ground mount, we just turn it off and it doesn't matter what brand of SKU you're sent.
Yeah.
It's like we're yanking questions out of people here.
Steve
Anybody
Johnson,
have
any
Steve?
questions, man? No, I'm asking Steve. You
Oh,
usually have some
gotcha.
questions. Throw something in there, Steve, or a comment. Crickets.
Well, it's like you're making people putting pressure on them to type quickly. I'm gonna try to open this up on the Everybody can comment. Talk. Allowed to talk. Allowed to talk. So attendees should be able to unmute themselves to ask questions.
Kyle, I guess I'll ask, what's our inventory looking like at the moment?
Full. So we've got about a total of 120 AMSs on hand, and I think Travis told me that we have a little more than half of those are reserved, or a little less than half, I should say, are reserved on sales orders for projects that are up and coming. So we've the various sizes. We did stock the 5 kW, the 7.6, and the 9.6. And I think, Travis, if I'm not mistaken, we have 11 4s on PO at some point here. And if necessary, the other sizes, of course, we can get readily. For example, we just had a special project come in for 6 kW that we ordered. So that's what the stock front looks like anyways.
Cool. Got a question
You
from
can't-
Paul Gabby.
You want to take it, Harrison?
Yeah, it says, is the physical layout design or setup the same as other brands or better / easier?
Well, the physical layout, let's put it away the typical workspace you need. I showed a diagram of, and I'll do it again here. Let me get back over. I'm go in display mode. Go a few slides and then I'll share. Where is it? Got a lot of slides. Okay, let me share this.
Is there a string builder? Maybe you're doing it right now, but is there a string builder tool or anything?
There is something online called Easy Designer 2 on the GoodWe's website. I created my own tool. It's in Excel, and so I can always do string sizing or verify string sizing for you. We are on some popular platforms. So off the top of my head, I know we're on Aurora Solar. I assume we're on ETB, but not positive.
We use both
So-
of those anyways, so that's good.
Okay.
I was playing over with Easy Designer yesterday. It's fairly easy to do. I mean, all you need to do is to have a SEMS account, and you can set up your default settings, like your preferred module. You can upload your own module, if it's not in the database. The weather settings can also be set up. It's just very personalized, and going through the whole process is rather easy. So if the real challenge is determining how many modules go into each string, into each inverter, into each MPPT, it's fairly easy to go through the whole process. And it really takes me like 5 minutes tops to go through a full energy storage system.
Awesome.
Chuck, you still with us?
Either that or he's thinking really hard. I think this is the screen share.
Hey, Chuck, you're still there?
I just came back, so I'm keeping my video off.
Then
It's
for
just that Zoom doesn't like my face, so I'm gonna just show my screen. Sorry about that.
some people have that problem.
All right, share screen. So if this is working, it says my screen is loading, and you should just see the placement of the inverter.
Yep.
This stuff is pretty typical that you don't want the inverter tilted sideways. Some inverters can lay flat. This one has to be vertical. Our three-phase can be laid down, but the single phase has to be vertical. In terms of mounting, what is unusual, the fact probably that we have two mounting brackets for this generation, the next isn't that way. So we have to definitely get people to use the template. Otherwise, it's a lot harder to get the holes lined up if you try to do it by hand.
Yep, and that template is the first thing in the cardboard box. So as soon as you pop open the box on the tape side, it's the first thing it pulls out as an independent piece of cardboard. And it makes it pretty easy.
Yeah, I highly recommend that you use this, not only because it's easier to do, but then you may want to keep one. If you're doing multiple installs, which we hope you are, sometimes people trash these things, and you've got one in the van, in the truck. But I think people will learn their lesson after doing that once or twice, not to trash the template. So in terms of wiring, we've got 6 1-inch holes. So they're pre-drilled, and they just have these rubber coverings on them that you unscrew. There's a little tool in the bag to help you unscrew these. Did I get lost again? Am I still here?
No, you're good.
Okay, good.
We got
All
you.
Okay, so these are 1-inch openings. I've told them, the 3/4, half-inch, 3/4 is more what people were used to. I think we're doing more 3/4. So you have to remember to bring some, if you're not going to do 1-inch, understandably, some reducing washers to get it down to 3/4, whatever trade size you're using. But these are NEMA 4X type coverings. So if you take one off, make sure you put, and this is outdoor inverter, you're putting nice rain tight conduit bushings in there. So that's the general bringing things in. I think one thing we want to learn, and for all these NEMA 4X, if you have, and let me get the pointer out here to make it easier. If we have conduit coming down and immediately turning in here, if water gets into that conduit, yes, it will go in here with no way out. So that's why it's often good to come in the bottom, or to come down to an LB that has a drain in it. So, sort of mostly one-way drain, sort of gravity drain that lets moisture drip out, and then the wires come in. You also can get electrical putty to stuff in the hole to help keep moisture out. But that's always the thing with the NEMA 4X versus the 3R is once you get water in, it's hard to get it out. So you want to prevent it from getting in. Some people will even take, and I'm telling you what to do here, but some people take conduit or tubing and do a bend in it, come up in, and then they'll do a weep hole in the conduit as a drain. I'm not telling you, I'm just giving you solutions that people have used in the past.
I say no, nothing on the side, in my opinion. I mean, we've
Yeah.
just seen it too many times to where that critical step is not done in the end on getting water in the side on a torrential downpour is generally when it happens.
Yeah, so there you go. The advantage, we got 4 openings at the bottom, so there's plenty of conduit room there. So you shouldn't need to use the sides. Good point.
Hey, I just realized Gabby's question. So he is referencing, he's thinking about it like there's optimizers or there's serial numbers underneath the modules.
Yeah, so since we're doing string level optimization, we don't do module level monitoring, which is something that is often sold, at the quote at the street level, at the homeowner level, as a great feature. Of course, it's something that's required. If you're selling optimizers or microinverters, you have to do that. Otherwise, you can't see what your device is doing. You have to have some sort of peek into it. And as much as people call it module level monitoring, it's really device monitoring, the optimizer and the microinverter itself. We're looking at how that's doing. We happen to be connected to a module, so we can also report on the module, but that's what it's really doing. And since we don't have any devices at that level, we just report at the string level what's going on. So if that's a requirement, then the solution isn't going to get you module level monitoring, at least not at this point. We may down the road provide a rapid shutdown solution that has monitoring in it, but not right now.
Yep. And to expand on that, what our job on that side is we would need a transmitter to add into the system and optimizers from a brand called Tygo. If we were to be coupling it with this product here on the AMS series. So we would if we were to do optimizers, which we can do, which would be the brand Tygo, and we would need a new transmitter, an additional transmitter, and deactivate the current one, I assume, and add in those Tygo optimizers underneath the modules.
Yeah, it'll all be except for the disconnecting of the power to, for example, in here, this Tygo transmitter. I mean, you would disconnect the power to it so you don't transmit out anything, and then you hook up all externally to this inverter. The Tygo solution you're talking about. Yep.
Well, we are at an hour, and I would like to, unless, you guys have anything else you'd like to present, I want to say thank you to both of you, and thanks for your time and walking us through the product. This is only, one step, and I expect a lot of movement with your product out there with installers and projects, and we're very excited to have you as part of the group.
Thanks, Kyle. We look forward to supporting you. I do, particularly on the pre-sale side, and work with anybody where it's string sizing or just questions about the inverter. Your team or installers, you decide how best you want to leverage me, but I'm your tech support on the pre-sale side.
Hey, Jacques or Brilio, would you mind also sharing some installation photos you guys have when you send out the recording? Just some installs that look nice so we can share those as well.
Sure.
Yep. Let's
Cool.
get those, Mallory, Emily, and myself. We'll send those out as well as a recording. All right. Well,
Awesome.
everyone,
All right,
have
thanks.
a great rest of the day. Thank you for your time today, and talk to you soon.
Thanks, everybody.
Bye.
Thank you,
Cheers.
guys.
Bye.
Have a good one.
Bye-bye.